Hi, Chris.
Hi. Hi, Tina.
Hi. Thank you, everybody, for joining us this evening. We are coming to you from Southeast Michigan. We do have some storms rolling in, and so the topic is very front of mind for us today here in the southeast portion of our state. Before I get to our presenter tonight, Chris Edwards, I'd like to introduce you all to my organization, which is EDF Action. We are the advocacy partner of the Environmental Defense Fund. We build support around strong climate policies that benefit the health of our communities, our economy, and help us reach the net zero goals that are necessary in fighting the worst impacts of climate change. At EDF Action, we support EDF's focus on science, law, and technology to advance good public policy that leads to action on climate. EDF Action is active in over a dozen states from east to west, collaborating closely with partners and allies, community members, and advocates towards meaningful progress on climate. Community power is political power, and we're on our way, and we're so glad that you're here to be part of it. So just a couple of housekeeping things before we get started. First and foremost, if everybody, I see that there's lots of people introducing themselves in the chat. If you're here joining us through the YouTube link or on Facebook or Twitter or however you're reaching us, please go into the comments and put in your name and where you're zooming in from. We would love to know everybody who's on today, and we're just so thrilled that you could join us. So we will have a question and answer portion of this presentation. We're reserving 15 to 20 minutes at the end that you can either put your question in the chat while Chris is doing his presentation and we'll get to it at the end, or you can feel free to wait till the end and we can ask some questions, through whoever is posting at that time. So we'll try to get to all of them. And if we can't get to all the questions, I'll do my best to capture what's in the chat and I'll get them over to Chris and we'll try to get those answers back over to you. So this call is being recorded. I just wanted to let everybody know that ahead of time. Tomorrow, anybody who registered through our Mobilize link will be getting an email from me with some follow-up information. We'll also send a link to the recording. So if you wanted to share it out with friends or family who couldn't make it tonight, feel free to share it far and wide. And also wanted to let everybody know that EDF Action, I am the state organizer here in Michigan. If you are in Michigan, we would love it if you could connect with us by becoming an EDF Action member. I'm going to put in the chat a link that will take you to one of our online petitions, and that will add you as an EDF Action member. And the reason why that's so important is that we are going to be transitioning into campaign work starting after Labor Day. And we have lots of exciting events coming up that I would love to engage folks with. Even if you're not in Michigan, we have stuff happening across the country. So we would love to connect with you in that regard. So I will be providing some information at the end about some events that we have coming up. But for now, I will leave our link in the chat and hopefully we'll get some folks that will continue to engage with us after this presentation. So now I'd like to introduce our presenter tonight, which is Chris Edwards. He is a meteorologist and a climate change specialist. If you are in the Midwest region, specifically in Michigan, you may have already heard Chris speak on this climate change topic. He has lots of really great information. He's dedicated to his whole career into bringing awareness in the changing climate, and he motivates people of all ages to act. So if you're from, or if you're not, you don't even have to be from here, but if you're aware of Southeast Michigan news stations, Chris was a meteorologist on FOX2 Detroit and also WXYZ Channel 7. He's a 3-time Emmy Award winner with multi-year recognition from the Michigan chapter of the National Association of Television Arts and Scientists for Best Weathercast. And so now he's taking his talents and he is creating all this awareness around climate issues and weather changes that we're seeing, not just in Michigan, not just in the Midwest, but nationally and globally. So without further ado, I will pass it over to Chris Edwards. Thank you for joining us, Chris.
Thank you, Tina, and thank you very much for the introduction. And I am going to, in a moment, add just a little bit more of what's pertinent to what Tina said about my background. But first, just a couple of housekeeping sorts of things. I know it's 6 in the East, but it's 5 in the Central, and it's 3 out West, and we have people from all over the country, and I'm glad that you're all here. But I'm going to tell you right off the top at 6:09 Eastern that we are going to rock and roll here. We're going to move along at a pretty good clip because there's a lot to cover. And I want to hear your questions at the end. So we want to get as much of that as we can. Just remember, as Tina said, you're going to get a link if you need to go back and look at something later. I know I've done it many times on presentations myself that I've watched. You'll have that option. It'll be easy. So if I go a little bit too fast, please recognize trying to get through a lot and trying to get to your questions. Having said that, anytime you see something on the screen that you think is interesting, if you want to hit a screenshot, go for it. No problem. You can do that and send them wherever you want to. I have no issues with any of that. I want to thank the EDF for having me here. It's wonderful to have this forum. If you have a question when I'm going through this, please jot it down. I want to try to keep going because later in the presentation, your question might get answered on its own. Otherwise, there'll be robust time in Q&A. I love to hear your questions and I try for the answers, but I'll tell you right off the top, I don't have all the answers. I just try my best. Now, a little bit more about my background and what's important. I started studying what was called the greenhouse effect at the time. It was most often called the greenhouse effect, but it also was called global warming back in 1987, as I was an environmental reporter at a television station in Milwaukee, Wisconsin, which is very hot and humid today. We started at that time. I was reporting as an atmospheric scientist on a strongly supported theory. I had some questions myself, but it was a strongly supported theory with some elements that were beginning to be seen and the beginnings of computer models that were telling us things that were going to happen in the years and decades ahead. I have the unique perspective in 35 plus years during the course of a career of having watched that unfold from going to a strongly supported theory, not well understood by the general public, to something that is bringing us headlines every single day and has so many facets that there's no way to cover it all in an hour. We'll do the best we can. This is Climate Change 101, and we're going to get started and make sure that everybody has a good, solid support, not only in knowing what it's about, but in knowing what to do, because what we're talking about today is that climate change is simple, serious, and solvable, and more on that is coming up. But I first want to give a thanks to the folks at the organization called Climate Central. Now, Climate Central is a policy-neutral nonprofit news organization. All they do is analyze and report on climate science. I've been working with their meteorologists since 2008 when they got started. And what follows this afternoon is a presentation of facts that is derived from the latest scientific consensus. So with that in mind, as I said before, it serves as an outline. Climate change is simple, serious, and solvable. We're going to go through those one at a time because it is one of the biggest challenges we face, and there can be confusion, but we're going to make it as simple to understand and talk about the serious and solvable nature of it one step at a time. And I don't know about you, I'm a generally simple guy. I like to start with simple. So let's start with the basic idea of climate change, and that is that humans burn fossil fuels. We're talking about coal, oil, and natural gas. We started burning them in that order. This burning puts carbon dioxide, also called CO2, I'll use those interchangeably, into the atmosphere. And CO2 is a greenhouse gas. It makes the planet warmer. It's not the only one. We'll talk about more in a moment. But CO2 is a big one. And that's as simply as we can put it but let's go into some more detail, because what we're talking about here is our atmosphere, which is 99% nitrogen and oxygen. But there are important gases that make up the other 1%. It's 78% nitrogen, by the way, and 21% oxygen. But those 1% that remain, even though they are in small amounts, they have a huge impact on our planet and particularly on our climate. I'm talking about water vapor, carbon dioxide, methane, and nitrous oxide. But particularly, we're going to focus on the two in the middle, carbon dioxide and methane. Those are the two that have the greatest impact and that have the biggest effect on what we're talking about in terms of climate change. So let's go back to the greenhouse effect. This may take some of us back to high school, maybe earlier, maybe later. Maybe it's something you just learned about fairly recently. It's good to take a very brief time and go over what the greenhouse effect is. I mentioned that back in the 70s and 80s, that was kind of a misnomer for this entire influence. And it's not the right phrase for it, but it's an understandable phrase for it. The greenhouse effect starts with the sun. It's 93 million miles away, but it sends us, of course, a lot of energy. Sunlight reaches the earth from that far away, and some of that energy that reaches the earth is reflected back into space. But some of that energy is absorbed and then re-radiated all over the globe as heat and absorbed as heat. And it's a really good thing that happens, because what happens then is that most of the heat is absorbed by those greenhouse gases and then radiated in all directions, warming the earth. Now, if we did not have the greenhouse effect, which we have had for millions and millions of years, if we did not have it, the average temperature on planet Earth would be about 0 degrees Fahrenheit, as opposed to about 60 degrees Fahrenheit where we are now, though that number, of course, is rising. So even though they are in small amounts, these greenhouse gases make the planet livable. Without them, it would not be livable at 0 degrees Fahrenheit on average. But slight changes in the greenhouse gas concentrations can alter the climate, and it alters the world around us. Now, the science related to this actually goes back a long way. A few key discoveries, the first of which was 200 years ago. Back in the 1820s, a guy named Joseph Fourier in France proposed that there were gases in the atmosphere that were keeping the earth warmer than it would otherwise be. And then we go forward to the 1850s in our country, when Eunice Foote actually discovered that carbon dioxide warmed the air around it. I have to take just a brief stop here. Eunice Foote, a woman advancing science so long ago, talk about really going upstream against a lot of challenges. Eunice Foote didn't even get credit for those incredible discoveries that she made until more than 100 years later. So let's just hear it for a moment for women in science all over the world that are making massive advances and have been for a long time. They had some great people to lay down the tracks and see how to do something. Thank you, Eunice Foote. All right, back to Svante Arrhenius. In the 1890s over in Sweden, he actually calculated in the 1890s that a doubling of atmospheric carbon dioxide would raise the Earth's temperature by several degrees. And then in the 1930s, Guy Stewart Callendar was really huge in this field and in this work because he refined Arrhenius's calculations and he made the first climate projections that had been made. He assembled the first evidence for global warming. It's so important, the work that he did, that a lot of climate scientists call this entire effect the Callendar effect. So the science has been around for a long time. And what we know about the science is this: carbon dioxide plays a critical role in regulating the temperature of the planet. All the way back in the 1800s, we started burning more fossil fuels, particularly in the second half of the 1800s, as the Industrial Revolution kicked in. It was first coal, then oil, and then natural gas. Now, these gases, fuels as they were, fueled the Industrial Revolution. They raised the standard of living of millions of people all over the world. No doubt about it. They changed our standard of living worldwide in developed countries, but they also increased the amount of CO2 in the atmosphere. So if Callendar and the others were correct, we would expect to see temperature rise as CO2 increases. So let's look at the data. This is a plot smoothed out, of course, of carbon dioxide in parts per million in the atmosphere. And this goes back to the late 1800s when we started out kind of as a baseline around 290 parts per million. And it went up steadily until about 1970. It started to go up quite a bit more quickly than it had prior to that. And where we sit today, by the way, I purposely leave this at 2019 when we first put this presentation together, because at that time we were at 412 parts per million. We are, as of this afternoon, at 423 parts per million, a full 50% higher than we were in pre-industrial times. That's what carbon dioxide has done. So what has happened to temperature? Well, the temperature has gone up, as you can see clearly for yourself. And you can see when you look at the red line, it hasn't been in lockstep every year all along the line. No, it hasn't. It has at times diverged somewhat, but the trend is unmistakable. As CO2 is increasing, it is causing the planet to warm. Now let's go back farther looking at CO2, because people often say to me, hey, the climate has been changing for millions of years. And they're absolutely right. The climate has been changing for millions of years. And CO2 concentrations have been changing for millions of years and have been partially responsible, largely responsible for driving those changes in temperature. But let's look at the CO2. 800,000 years is what you're looking at now, not just 140 years or so, 800,000 years. And you'll notice that in most of that time frame, CO2 was between about 180 and maybe 300. Okay, you can see it went up, it rose and fell, as you would expect to see in cycles. But what has happened in the most recent 100+ years is unprecedented in an extremely long time, and it's different for three big reasons. Number one, how high we've gone. You can see here, 423. We haven't been anywhere near that in not just 800,000 years, but probably at least 2 million. We just don't have the graph that goes back that far. Newer data shows we're probably at least 2 million from having been above 300 parts per million. That's the first difference, much higher than we have been before. Number two, and this is hugely important, so quickly we have gone up compared to the changes in the past. We have gone up very, very fast. We'll talk more about that and the ability or lack thereof to adapt as a result of fast change. And the third big change is that this has been caused by humans. The other changes have been naturally driven. And those three differences together make this a whole nother ballgame. Now, I mentioned at the beginning, carbon dioxide and methane were the two gases we were going to talk about the most. I will tell you, one of the biggest changes in the past 10 years, even 5, that we have seen in communicating climate change and what we're learning about it is that there's a lot more concentration on methane than there used to be. Few reasons for that, not time to go into them. One of them is that we can detect it much better than we did. But methane is very, very important. It's responsible for at least 30% of Earth's warming. Methane, though, the good news is, breaks down in 10 to 12 years. That's the really good news. A lot of times when we jump forward later to changes and things that we can do, a lot of times methane is referred to as the low-hanging fruit, because if we can knock methane from coming into the atmosphere in 10 to 12 years, it's gone, and it's a very potent greenhouse gas. So that's where a lot of concentration is going right now. The bad news about methane is that molecule for molecule, it's about 80% more potent as a greenhouse gas than carbon dioxide. Now, carbon dioxide stays in the atmosphere for hundreds of years. Methane, 10 to 12 years, it's gone. But methane, while it's there, is very potent, which is why we're showing increasing attention to methane and trying to reduce the emissions thereof, because big short-term payoff when we do that. By the way, natural gas is 70 to 90% methane. All right, now I'm just going to show you Michigan here. This is not that different in states all over the country, but this is where the methane emissions come from. Almost 30% from energy, leaks and things of that nature. Agriculture, responsible for about 1/3 of methane emissions, and waste is 38%. Some of that is methane emissions from breaking down landfill material. But that's a rough idea of where the methane emissions come from. The good news is we have viable things to reduce the emissions in all three of those sectors. More on that coming up. All right, so let's bring it down to one spot, in just one spot. I know that we're all over the country. This is one spot in Michigan, Grand Rapids, and this shows how temperatures on the ground back to people's childhoods have changed since the 70s. It is not just your imagination, it's getting warmer. Average temperature in the whole decade of the 70s in Grand Rapids, average out the high and low for the entire 10-year period, it was about 47. You see in stair step, it has gone up until the most recently completed decade, near 50. So in other words, that translates to about 3 degrees Fahrenheit of warming in Grand Rapids. May not seem like a lot, but just think for a second about when your temperature is 98.6 and you're normal, and your temperature is 101.6, you're 3 degrees warmer. In some instances, and when we talk about average temperatures in the earth, 3 degrees Fahrenheit is a big deal. Let's look at Vegas just for fun, because I know there's some people on the call that registered from Vegas. Well, obviously the numbers are different. In the 70s, they started out at 66.5, and in the most recent decade, we're 71. It's even more warming in Vegas, and it very much has gone on a stair-step basis. We could look at these for cities all over the country and see some different patterns, a lot that are similar, if we only had the time. You get the idea. That's one spot and how it has warmed overall over decades. Now, we're at Detroit in this one. The point I want to make in this is that the seasons haven't warmed equally. Through most of the Great Lakes and Midwest, we see a similar pattern to what we see for Detroit, and that is the biggest change has come to winter. Winter is the one of the 4 seasons that has warmed the most. Spring, by contrast, is the one that has warmed the least. And summer and fall, not far behind winter, have each warmed rather significantly. Now, in some parts of the country, there have been seasons other than winter that have warmed the fastest. But in most, certainly in the Midwest, Great Lakes area, it has been winter. But it doesn't warm equally. Just like climate change affects all of us, it doesn't affect us all equally. Same with the seasons. Not all the seasons are impacted in the same way. All right, now for this next graph, we're going to work out to the whole world again. We're not looking at one point around the United States. This is the entire planet and the hottest years ever recorded on record. And when I started reporting on climate change in the 80s and the 90s, I would look at the 10 hottest years ever, and I would see 1943 would be in there, and 1935, and we'd see a 1903. Look at the bottom of this graph. And when you see the years that are the 10 warmest years ever, they are, I'll spare you having to look at it really closely. It's the last 10 years. Now, they're not in order because it hasn't worked out that way. But what is very significant is 2023, also known as last year, was not only the hottest year on record, it wasn't even close. It smashed records for the hottest recorded temperature all over the world that we had ever seen. We'll tell you right now, that was driven by 2 things, climate change and El Nino. El Nino is a seasonal change in patterns of weather all over the world that, among other things, drives temperatures up. So when you have the big overall category of climate change, and then you superimpose over on top of it El Nino, which we had last winter and has just now faded in the last couple of months, you put the 2 together and you've supercharged last year. 2016, the second hottest year we've ever recorded, that was also an El Nino year. But the point is clear that we are still having a very, very hot year here in 2024. We're almost through our 8th month, and it's looking likely, unless things really change, 2024 may actually surpass 2023 as the hottest year on record. We continue to see similar sorts of things when we look at temperatures all over the world. So let's talk about future warming, because we know CO2 affects temperatures. I mean, we've seen some examples of that. The climate scientists use sophisticated computer models to predict how the Earth is going to respond to rising CO2 in the future. Now, the earlier versions of these models I started looking at in the 80s predicted the recent warming that we have and other things that we'll talk about, not just the warming. But the models now, which are much more sophisticated than they were in the 80s, are telling us two really important things. Number one, lots of CO2 emissions will lead to lots of warming. That's the red path. And if we stay on the current path, we get to 8 degrees Fahrenheit of warming all over the world. And I will just tell you right now, that is not a recognizable climate around the world if we get to that much warming. And that would be by the end of this century if we continue on the present path. On the flip side, if we reduce emissions, we reduce how much we warm significantly. The bottom line is the longer we wait, the worse it will get. We have squandered some time talking about what has happened, projecting briefly into what could happen in the future. More on that as we shift to the second of our 3 topics, which is, of course, serious, because the warming leads to other things. It leads to changes in the atmosphere, changes in the ocean. That is climate change. It is not just about warming. And we're already seeing wilder weather and rising seas that are some of the hallmarks of climate change that we expected and that are happening. Now, we talk about averages because they're a very easy way to understand overall trends, all the way back to our averages that we dealt with in school all the time. When we talk about averages with temperature, it's important to note that when you slide that bell curve over, when you do that, you get quite a bit more heat and extreme heat on the right-hand side. On the flip side, when you move those averages over a rather modest amount, 3 degrees Fahrenheit, for example, you get less cold and less extreme cold. I didn't say no cold. Nobody ever said that climate change means extreme cold goes away. No, there's some fascinating work lately that shows that this disruption of the jet stream patterns actually tends to break off more cold air from the Arctic and Antarctic regions than we used to see in a pre-climate change environment. But they don't last very long. They're not deep and they don't last very long. That research continues. It's very, very interesting. But one of the hallmarks of climate change is not just warming, it's more variability in the weather. What the average person will often call more wacko weather. And that is what we expect to see, are seeing, and will likely see as we move into the future. And speaking of that, one of the ways we keep track of how weather impacts us, it's just an arbitrary thing that meteorologists and economists came up with back in the 80s to say, hey, we're going to keep track of all weather events that cause at least $1 billion in damage in this country. This is for the United States. And you'll see on the left-hand side, back in the 80s, most years we saw 5 or fewer events like that. I'm talking about hurricanes, severe thunderstorm outbreaks, ice storms, wildfires, floods, anything like that. Okay? We didn't see all that many back in the 80s, but notice how things have changed to, I mean, I could go over the last several years, but let's just go over the most recent, 2023. In 2023 alone, there were $28 billion disasters in our country. By the way, these are inflation adjusted. So this is on an even keel in terms of what the dollar is worth. But in 2023, there were 28 total billion-dollar disasters, $93 billion overall in damages. So when people say, you know, making the changes we need to make to reduce our emissions is going to be really expensive, they are absolutely correct. It is going to be really expensive. But think for a moment what doing nothing costs just in terms of dollars and cents. We're not talking about livelihoods. We're not talking about homes and homesteads and lives themselves. We're not talking about any of that. We're just talking about dollars and cents. Not doing anything is very expensive also. And by the way, we're almost 2/3 of the way through this year. We've already had $19 billion disasters. So we're right about here right now. Let's cross our fingers that it doesn't get much worse, but only time will tell. One of the things we know that's happening with climate change is that snowfall patterns are changing and rainfall patterns are changing. I know that some of you live in parts of the world where it doesn't snow at all, parts of our country where it doesn't snow. I get that. Every area has its own changes that are happening. We'll talk more about more intense precipitation coming up very soon, but each area has its own different things. For example, milder climates climates are getting less snow and more of the precipitation is falling as rain and less as snow. Late fall and early spring might be rain where it used to be snow. The mountains of the West, more of the precipitation tends to fall as rain, which means it doesn't get stored in the summertime to be slowly released as drinking water it gets stored in the wintertime, so it can be slowly released as drinking water in the summer. That's an age-old pattern, and it's changing as more of that precipitation in the winter falls as rain, less as snow. Very quickly, I'm going to give you an example from the Great Lakes, because I know we have a number of people in the Great Lakes. I have had people send me videos and say, hey, what so much for climate change? It's snowing so hard right now from lake effect snow, I can't see my hand in front of my face, a foot in front of my face. So much for climate change. The interesting thing about that is that climate change models have been telling us for years that lake effect snow, which is bursts of heavy snow, moisture coming off the Great Lakes, would become more intense with climate change. And here's a very brief on the reason why. The lakes don't ice over as much as they used to. So since they don't ice over, they can add moisture into the atmosphere. There can be more warmth. Warmth leads to higher precipitation content, leads to higher moisture content. And so instead of a 1 to 2 inch an hour snowfall, you can easily, in a climate change environment, see a 3 inch an hour snowfall. And that's because of climate change, not in spite of it. And little changes like that vary from place to place because climates are different. There are little changes like that in precipitation and weather patterns all over the world. And some of them, like lake effect snow change, we understand pretty well. Some of them, not so much, but they're changing everywhere and having a big impact as they do that. And speaking of change, I could show you some amazing pictures of receding glaciers from all over the world. I could show you 45 minutes worth, and some of them are actually incredible. They grab your attention, but we don't have time. I can show you one. This is the Bear Glacier in the Kenai Fjords of Alaska, a beautiful area. But in just 7 years, this particular glacier receded immensely in the 7-year time between 2012 and 2019. Now, you might say to yourself, that's really sad. We don't want to lose glaciers. There's a tourist aspect of that. It's really a bummer if they go away. And those things are true. But there are two important things to remember about glaciers receding also to keep in mind. Number one, millions of people around the world rely on glacier water that's melting for their drinking water. So when the glaciers disappear, so too does the water they drink. Number two big issue, you may or may not have heard of it. You will in the coming years more. It's called glacial lake floods. And basically, as a glacier melts, just like a river can dam with ice in the spring, it gets dammed up, water backs up, it backs up until it puts a tremendous force on this decaying ice that is acting as a dam. It breaks suddenly without warning, usually in areas with very poor communication, and people lose their lives. It's happening more and more and more in mountainous areas and areas that have glaciers around the world. Glacial lake flooding is a sign of how humans have to deal with what glaciers are doing as they recede. But it is not just land that is heating up. It's really important for us to remember that the oceans are heating up too. As a matter of fact, the oceans have absorbed over 90% of the extra heat that we've put into the Earth's atmosphere, like a sponge. But even the biggest, best sponge can only hold so much water. And oceanographers are telling us that the oceans are getting really close to where they can't absorb a whole lot more of that heat that we're putting into the atmosphere. Now, I want you to take a look for a moment, and I'm going to point it out. This is all this orange and red and brown. These are all indications. This is where the ocean waters over the data period, which is 120 years or so, this is where the ocean waters have warmed up. They've warmed up in a massive way in a lot of places. This is a data void down here near the Antarctic because of map projection issues and all. But the red and orange show where the oceans across most of the oceans of the world. And remember, the oceans are almost three quarters of the planet's surface. They have warmed. But notice, you might have already seen it for yourself right here, right here south of Greenland, this little blue area. I know when I first saw that years ago on one of these maps, I thought it might be a mistake. Ladies and gentlemen, it's not a mistake. It shows up year after year after year. And I'm going to give you 15 whole seconds to think about why it might be there while I take a sip of precious water. You probably figured it out, but I'll confirm what might be on your mind. That ocean water is colder than it used to be because the glaciers on Greenland are melting fast and pouring millions of gallons of very cold, non-salty water into the North Atlantic. They're doing it every day, most of the year. They're doing it every year, year after year. And it is changing patterns that are driving weather systems all over the world. It's ocean currents which drive weather patterns. That's what El Nino is all about. And we have this, I imagine you've heard of it. We have this up the eastern seaboard. We have the Gulf Stream, which moves northward as a warm current. And that Gulf Stream keeps going up into the North Atlantic. And then it hits those waters of the North Atlantic where that cold, not salty water has hit the North Atlantic, and the jet stream gets really whacked out by that. All right. And it disrupts it, and it doesn't know exactly how to handle it. Now, scientists have observed this a long time ago. It, of course, has an acronym because scientists love to have acronyms. It's called the Atlantic Meridional Overturning Circulation, or AMOC for short. It doesn't really matter what it's called. What matters is, what does it mean for weather patterns around the world? And unfortunately, we don't know. We don't know. We know it's very significant. We know that Western Europe can't stop studying this because their weather patterns come from here and they are being disrupted. But basically what we are doing with the planet and the AMOC is we are conducting an experiment. We have some theories about what's going to happen. We have some theories that weather patterns might not completely be disrupted. And we have some theories that say they could be. We don't really know. But as long as we keep going the way we are going, we're going to run this experiment and we're going to see what happens with this experiment. That's the truth. As I told you at the beginning, what we would deal in. Now let's look at sea level rise, because as those waters have warmed, they have also gotten higher. Sea level has been going up. This is a graph of the last 20 centuries or 2,000 years. What has happened with sea levels? And you can see for yourself. Each bar is 100 years. And in past centuries, the sea level might go up an inch or down 2 or up 2 or whatever. In the 11th century, they actually went down about 2.5 inches. That was rather interesting. That was the biggest diversion we had seen from sea levels in 2,000 years until the 20th century, when we went up almost 6 inches. Now, may not seem like very much, but it is the biggest change in sea level in over 2,000 years, and it is accelerating. The biggest reason, by the way, I want you to know this, even if your friends you talk to might not be clear on this, the biggest reason sea levels are going up is not because glaciers are melting into it. It's because warm water takes up more space than cold water. One of the basic tenets of physics, when you warm up the water, it takes up more space. And I just showed you we're warming up the waters of the world dramatically, and so it's taking up more space. Now, this is what happened in the 20th century, almost 6 inches of rise. We are already, believe it or not, almost a quarter way through this century, and we have already seen about this much, between 4.5 and 5 inches of rise already in the first quarter of this century. So if you just extrapolate that out, it's quite a bit more than what we saw last time. And unfortunately, we can't really just extrapolate it out. We're accelerating in terms of sea level rise. How much sea level rise will we see by the end of the century? There's a lot of debate about this. But I can tell you, number one, it will not be a 1/4 inch. It is likely to be somewhere between 2.5 feet and up to 6 feet. I know that's a big range. Oceanographers and climatologists are working really hard on this because it's extremely important. Because as the sea level rises, not only do we have more flooding, we have some areas that become uninhabitable. There are hundreds of millions of people around the world that live within 30 feet of sea level. And so this really matters, and we will continue to watch it very closely. But one of the most important tenets, along with water takes up more space, warmer water takes up more space, that I hope that you can walk away with this afternoon is that warmer air holds more moisture. So warmer water takes up more space, warmer air holds more moisture. I promise there won't be a quiz, but this is really important because when you warm up the air just 1 degree Fahrenheit, it can hold 4% more water vapor. So when you hear these stories about flooding driven in part by climate change, this is the reason the link exists. Because a warmer atmosphere holds more water vapor. Hey, that's why it's more humid in the summer in many parts of the country. We feel the humidity in a big way in the summertime, which we don't in the winter. It's that warmer air holding more moisture. An increase in temperature allows more evaporation into the atmosphere from oceans, lakes. I mean, it even comes from soil and plants. The moisture comes from a lot of places, but it makes more moisture available for storms. And that means rain or snow, depending on temperature. It means hurricanes have more moisture available as well. More on that in a moment. It effectively supercharges that water cycle we learned about in elementary school. It increases the amount of rain and snow in heavy precipitation events. This was predicted back in the 80s. There were a lot of people that raised their eyebrows and were skeptical about this. This is what is happening. Wet areas get wetter, but here's the part that might seem counterintuitive. Dry areas get drier. And the brief on why? Yes, warm air can hold more moisture, but if the moisture isn't there, it can't be precipitated out. If it's not there, it's not going to happen. So then you just have a warmer atmosphere, you have fewer clouds, and you have drier conditions. So remember something I said before, we have more variability. Wet areas get wetter, dry areas get drier. Drought can be more persistent. Wet flooding conditions can be more significant as well. And let's see how that looks around the country. And I know that those of you in, say, the Pacific Northwest that are looking at this, this is heavier downpours and how they've changed in basically about the last 60 years or so. And in the Pacific Northwest, that is the one part of the country, the significant part of the lower 48, that hasn't seen a significant increase in heavy downpours. But many other parts of the country have, especially the Northeast and the Midwest, 60% more heavy precipitation days, precipitation on the heaviest precipitation day. So when it rains heavily, it rains more heavily, 60%, than it did just 60 years ago. And you can see in different parts of the country, it's 24% more in the Western High Plains and 37% more in the Southeast. But it is a common, it's a common factor that is happening and makes the news on a very regular basis. For instance, just last weekend, 17 inches of rain in Connecticut, fatalities. That was not from a dying tropical storm. That was just from an old frontal boundary that stalled. The moisture was there. The warm air held more moisture. We have a higher chance of that sort of thing. Not saying that climate change causes it. There is a higher chance of that sort of thing because of the way that the atmosphere has changed. Statistically, we're seeing it. This is how it looks in one city. This is the city of Washington, D.C. Surrounding areas are similar. And basically what this is showing us is when it's raining in D.C. compared to 50 years ago, it rains harder. It used to rain on average 6.5 hundredths an hour when it rained. And now it's raining on average 7.5 hundredths of an inch per hour. Again, the absolute numbers may not seem all that significant. The point is that on a percentage basis, when it rains, it's raining harder. And that is something that we're seeing in many, not all parts of the country and not all parts of the world, but in many parts of the country and the world, that is something that is showing up statistically again and again. A couple of brief comments about hurricanes and climate change. We're not going to spend a whole lot of time on it. Thankfully, our hurricane season, except for Beryl last month, has been relatively quiet so far against predictions, but we'll see. Hurricane season has some time left to be sure. But the major things to know about hurricanes is that in a warmer world, warmer water is the fuel for hurricanes. So when you have warmer water, you have more fuel for hurricanes. That doesn't necessarily mean they're going to be more hurricanes. The latest science is that the amount of hurricanes may stay close to the same. The amount of hurricanes may stay close to the same, in spite of what you may have heard from talking heads in some places. But the intensity of the hurricanes is likely to be stronger. Heavier rain because of things we already talked about, a higher storm surge, in part because the baseline sea level is higher to begin with. And there's also been some fascinating research in the past 5 or 6 years that in a climate change environment, hurricanes, as they approach land, are slowing down. And the physics of the models is showing us that it will probably continue to see less rapid movement of hurricanes as they approach land than what we used to see. That's bad news. If you're going to see a monster move through your neighborhood, you'd much rather see it move through at 30 miles an hour than 10 miles an hour because of the damage that it can do. We're continuing the research on that, but that's a little overview of hurricanes and climate change. And those of you that live in and are very interested in that particular aspect and the geography of that, we can talk more about that later if you'd like. Now, on the flip side, and I'm sorry, this is not a great graphic. It's a little wonky, but basically going back to 1900, wherever you see this brown line going down, this has been a drought. And the farther downward it goes, the more extreme the drought has been. And the more they're bunched up together, the more persistent the drought has been. So with that little overview, you get the idea. Droughts in the Western United States are getting longer and deeper and more significant than what they used to be. This is part of what the models projected would happen, and it is. Up until about almost 2 years ago, much of the Western United States, Great Basin into the Sierra deserts of the Southwest, was in the worst drought in 1,200 years. The last couple of winters have been fairly kind, and that's wonderful news. But the overall trend hasn't changed. We still expect that dry areas get drier, and we're seeing an increase in extreme droughts, and we need to plan accordingly. A little bit more about Sirius. Like you say, oh, you haven't talked about Sirius enough. Yes, nature, health, and the economy are being impacted as well. Now, most of the things shown in these pictures I've already talked about, but I have not talked about wildfires. And wildfires are very significant because as it dries and as it heats more than it used to, wildfires are becoming more intense and more common. I just finished reading a study a couple of days ago, big, long study that showed basically in the last 20 years, severe fires have become twice as likely as they were 20 years ago. Now, as we saw last summer in a large swath of the northern third of the United States, even hundreds of miles away, a wildfire can have a big impact on us because it degrades our air quality. It makes us have to stay inside. It makes being outdoors, in some cases, downright dangerous. And though that is just one of the factors that we are seeing happen more often. And part of the reason, too, is that climate change drives more insect infestations, which kill trees and add, in many cases, to the wildfire threat as well. Now, animals and ecosystems are impacted in a very big way because the natural world, remember, we're just one species. We may control a lot of things, but we are just one species. And these animals and ecosystems are adapted to specific climate conditions. And as the climate warms, many of these things that can are moving north or poleward, or they're moving up to a higher elevation if they can. And they're doing it because adaptation is part of what the natural world has been doing for literally billions of years. But remember what I said before, the speed of this transition is not like anything we've ever seen before. A very brief little example of that from us here in Michigan and the walleye, a study that we finished this spring on walleye that was multiple years. The walleye are adapting. You see, what the walleye do is they spawn when the ice breaks up. Okay, so they get used to the ice breaking up, March, maybe, whatever the case may be in a particular location. But the walleye for many generations have spawned in March when the ice breaks up. Well, now the ice is breaking up earlier. It's not breaking up a little bit earlier. On average, in Lake Michigan shores, the ice is breaking up about a month earlier than it used to. Now, what they found is that the walleye have adapted marvelously. They're spawning a full week earlier than they used to. And in a period of 20 or 30 years, that's really rapid change for a species to do that. The problem is it's not fast enough. They're spawning a week earlier. The ice is breaking up a month earlier. There's a mismatch. And so the numbers of walleye are declining because they're not able to adapt quickly enough. Many people will say, hey, we adapt, the earth adapts, animals and plants adapt. And those are all true statements as they exist right there. But how quickly the adaptation can occur depends on the species that we're talking about, depends on the area that we're talking about. And in many cases, like for instance, you see this picture of the coral reefs with the angelfish by it. The coral reefs can't adapt fast enough to the bleaching from the heated waters of the oceans all over the world. We get these mismatches between predator and prey that are severely impacted. And yes, they may move north, or they may move higher up the mountain, but eventually they run out of land, they run out of mountain, and species are in serious trouble as a result of that. So let's talk a little bit more about our own health, though, because back to we humans, the ones in charge, warm conditions make air pollution worse. Climate change amplifies some of the sources like wildfires, as I talked about, and CO2 sources. Whenever we still burn coal, we're adding to the pollution in the air, which is added to what is being put there on an additional basis because of climate change. Heat impacts us directly. It increases the days where physical activity outside is dangerous or at very least uncomfortable, especially important for outdoor workers, for athletes, for kids, for people that just want to enjoy. It makes it very difficult. And the heat impacts other species that impact us. For instance, mosquitoes, tick-borne diseases, they're becoming like Zika, malaria, Lyme, are spreading into new locations. They're sticking around longer. As growing seasons expand, many spots in Michigan, for example, have a 30-day longer growing season than we did just 40 years ago. And in just that period of time, you now have a longer allergy season. And you have a longer season when things that can be troubling in the warm season are a greater trouble to many people. Those risks of insect and foodborne diseases, even something like, even something as common as poison ivy becomes more of a problem in a warmed atmosphere, and we are having to deal with that. Food and farming are impacted as well. The way we produce our food is certainly impacted by floods, by droughts. It impacts the people that work those fields. The wild weather events, of course, can wreak havoc with the crops and the farmland itself. The planting zones, as I alluded to before, are having to shift. Agriculturalists are having to plant different things because as the climate changes quickly, it can't support the things that it used to in the past. Now, a lot of very fine universities are doing a lot of intense work on making these adjustments, but they're huge challenges. And crop diseases and pests are spreading and sticking around longer as well. That's enough of the serious. So at this point, we're going to start talking about solvable, because if I didn't think, with all my careful studying of this over 35 plus years, if I didn't think it was still solvable, I wouldn't be using your time, because I know your time is valuable. I do think it's solvable, but I will tell you right off the bat that when we start talking about solvable, we're taking a slight move from strict science to science-based potential solutions. Whenever you start talking about solutions, you're talking about policy. And whenever you're talking about policy, you're not strictly in the sphere of science. I just want to make that really clear to everybody. It's very clear to climate scientists that in order to prevent the worst of the issues, we need to make big cuts, and we need to make them fast. You may have heard about the World Climate goal of trying to keep us to 1.5 degrees Celsius, or that's about 3 degrees Fahrenheit. Sorry, we're going to switch back and forth between Celsius and Fahrenheit a little because we're about the only major country in the world that still uses Fahrenheit. So 1.5 degrees Celsius is 3 degrees Fahrenheit. The goal was set almost 10 years ago to try to keep us below 3 degrees Fahrenheit of warming. We keep pushing toward it, but in order to get there, we have to make big cuts and we have to make them fast. Most estimates say we need to stabilize CO2 levels and CO2 equivalent, meaning methane as well. We need to stabilize those before 2050, probably by 2040. That is really not very long in the big scheme of things. So we have to reduce emissions quickly, and we have to figure out some potential way to remove CO2 from the atmosphere. If we don't, we're on this red line toward the end of the century, an unrecognizable climate, an unrecognizable planetary system, quite frankly. If we make the cuts, it's a big difference. More on that coming up. So I know when I'm trying to get my arms around a problem, I want to, first of all, take a good look at what makes up the problem. So in our country, again, it's a worldwide issue. This is where we have the best data. Here's how we go about it. We've got 29% of our greenhouse gas emissions come from transportation. Almost that much from electricity, 28%. Almost a quarter from industry, 12% from commercial and residential, and 9% of our greenhouse gas emissions come from agriculture. Now, the good news is we have solutions for each of these sectors already, and they are being refined all the time. So let's talk about renewable energy, sometimes called clean energy. I want to call it renewable energy. On the left, that's solar. And the darker the shading, that's the more solar energy that reaches that part of the country. The deserts of the Southwest, as you might expect, get the most. But even across the northern tier and into the Northeast, there's a significant amount of solar energy which reaches the ground. Does it shine every day? No. But over the long period of time, significant amounts of solar energy hit all parts of the country. And on the right, in the blue, you're looking at wind energy. And the darker the blue, the more wind energy blows. The more the wind blows and the more frequently and at a higher intensity. Highest along the east slopes of the Rocky Mountains into the western high plains. But again, in many parts of the country, there is a significant wind energy potential that exists. And how are we harnessing it? The very latest data shows wherever you see the darker shading, those are states which are powering more homes in the millions with solar energy. This is solar, first of all. You'll notice that California and Texas are among the biggest. Hey, they're also among the most populous states, but they have really, really grasped onto solar energy. You see, there are some parts of the country where it's just not happening very much. That's solar energy. How about wind? Once again, Texas, which has a very interesting history of harnessing energy potential, has really grabbed on to both solar and wind, but many other parts of the country have done that as well. And there are some notable exceptions, certain parts of the country that as of yet have not. And if perhaps you live in one of those parts of the country, you can be a trendsetter. We need to electrify as much as we can, and we need to clean up the grid. So when we talk about solvable, when we talk about the window that is getting smaller but hasn't yet closed, one of the things that gets a tremendous amount of attention, with good reason, is how to electrify transport. We know how to produce electricity from renewable, that is, clean sources. We can use energy, that electrical energy, to move us around, move us from one place to another, move the things we want from one place to another. That's all about transportation. So we need to convert cars, buses, trains, all modes of transportation, even airplanes if we can, with sustainable aviation fuel. We need to move them from fossil fuels, internal combustion engines, to running on clean electricity. Electric vehicles are getting better all the time. There are some bumps along the way. The infrastructure needs to be implemented, but just a little factoid, 1,000 charging stations a day nationwide are coming online. It did not happen immediately when we got the internal combustion engine going in the early 1900s. It's not going to happen immediately and without speed bumps now, but that's the direction we need to go. And a lot of companies have just put out marvelous PR and said they're going to do some things. And some companies have really made a difference and really made some commitments. Very brief example, GM is not going back. Nope, they are committed to EV for better or worse. The R&D isn't even pursued anymore on the internal combustion engines. They're committed to be all EV fleet by 2035 and carbon neutral as a company by 2040. There are many, many companies that are doing similar sorts of things, but it isn't just transportation, of course. Part of the pie of our greenhouse gas emissions comes from producing better buildings. We need to use energy better to heat and cool our buildings. Architecture and building design can increase energy efficiency hugely. Simple things like improving insulation saves money and energy, increases comfort. Electric heat pumps. I wish I could do a quick poll of how many of you have heard of them, but most of the time when I talk to people, about a third of people have even heard of electric heat pumps. Electric heat pumps are a wave of the future. You are going to see and hear more of them in the years to come. They have been proven in other parts of the world that regardless of what kind of climate, hot or cold or in between, they work and they are cleaner. They are more expensive to install, but they are much cheaper to run over time, and they cool things in the summer as well. That's just one of the things that are going to be changing in the buildings which house us. We need to build better soils. We need to reduce emissions through better farming practices, reduce tilling, and have planting cover crops that can keep carbon locked in the soil more. Once again, tremendous amount of innovative research is being done on ways to do this, and it's bringing us new ideas all the time, but we need to keep pushing on it. And all over the world, this is going on. Little things that somebody can compost in their backyard or an entire agricultural system on the other side of the world can change. They all need to happen concurrently. And the more that we can maintain our natural carbon sinks and buffers, whether that's wetlands or grasslands or forests, as I'll talk about in a moment, it's important to plant trees. It's every bit as important to maintain trees wherever we can, to not disrupt them, because those not only soak up a lot of carbon, but they give us a buffer from rising seas and from storms and floods that, as I mentioned, are becoming more common. It helps to buffer it. Speaking of trees, wonderful old saying, the very best time to plant a tree is 20 years ago, and the next best time is today. And there's a lot to be said for that. And this is an example of one of the cities of our country, San Francisco, and what the trees in the city by the bay do for that community. They removed 90 million gallons of storm runoff, 200,000 pounds of air pollution each year removed, and 10,000 tons of carbon pollution. Just the trees that are already there. Now, some people have said, you know, what we really need to do to solve this problem is everybody needs to plant a tree. And, you know, in this country, that'd be 330 million trees, and that would be great. Unfortunately, as wonderful as that would be, it's not enough. There is no silver bullet when we talk about solvable. There isn't. We're going to need to do lots of things, and I'm just being honest with you. If there were a silver bullet, we'd do it. There might be silver buckshot. I believe it's Bill McGibbon that came up with that. There might be silver buckshot. We need to do a whole lot of things at the same time, but please don't delude yourself into thinking that if you plant a tree and you do a little better job on your recycling, that you've done your part, because that's not exactly the way it works. You see, this is a big challenge that we are dealing with. Arguably, the biggest challenge that the human race has faced to this point. Again, arguably, you can come up with some things. I'm a student of history. Here's what I know. I know that to stay close to keeping us below 3 degrees Fahrenheit, to stay close to that target, we need to make big changes. We need to make them quickly. But we have done big things before, and we have done them fast. On the left side, that picture represents indoor plumbing and electricity. When we implemented those in cities around the world, massive changes in not only quality of life, but length of life. Within 2 generations, we doubled the average lifespan just by implementing those sorts of things. Huge changes. People said it couldn't be done. Well, it was, and it made massive differences for millions of people. In the middle, the space age. You know, John Kennedy, I believe he was at Rice University in the early 60s when he said, "We choose to go to the moon not because it's easy, but because it is hard." And people laughed at him, and people thought he was a lunatic, pun intended, to think that we could get to the moon in less than a decade. Craziness. Well, I think you know how that turned out. And not only did we get there, but over the course of that time and beyond, we have learned so much more about our planet, the way it works, about the ability to monitor it, impacts that have affected us on the ground in ways we never could have imagined, that came about because we set an audacious goal and we went after it. And on the right, the internet, mobile phones, instant communication over the world. 17 years ago, we didn't even have iPhones. 17 years. It doesn't seem like very long. It really isn't very long. It's about the scale of time we have to make massive change. But what did that do? It changed the lives of hundreds of millions of people all over the world in unimaginable ways. We have to make big changes, but reducing emissions is a win-win. It is an economic win. It is an environmental win. These changes create jobs and they create new industries. Is there disruption? Absolutely, yes. There's no way around it. Disruption is in our future. We can control part of how it is that it happens. And the last couple of graphs I want to show you talk about warming over a lifetime. I promise, I know I've shown you a lot of colorful graphs. I want you to understand this one for real, because what's across the bottom is not years. These are generations. These are people. These are people in this country that you've heard about. The greatest generation, the silent generation, the baby boomer generation, the Gen X, millennials, Gen Z, and the Gen Alpha. And I know when I first saw this, I said, who's Gen Alpha anyway? Well, some of them haven't even been born yet. And they're all 10 years old or younger. But here's what's important about this, is we look at what warming has done and what it will do. The hatched areas on this graph, ladies and gentlemen, are changes that have not yet happened, but will happen if the carbon pollution continues the way we are producing it now. So what that means is Gen X, by the end of its time on the planet, will deal with almost 6 degrees of warming. Millennials, more than 6 degrees, 7 degrees for Gen Z, and those poor Gen Alpha, some of whom haven't even seen the light of day yet. We'll deal with that 8 degrees Fahrenheit of warming that I said brings about an unrecognizable environment. That's if we don't make change. And I don't know about you, but I think a little bit sometimes about when I'm not here anymore and when I'm not vertical anymore. And if we make the changes that I'm talking about, if we make the changes that we've targeted, this is what will result. Yes, there will still be some warming. Some of this is baked in the cake, but look at the difference. Look at the difference, especially out Gen Z, Gen Alpha, some of whom haven't even born, none of whom are in positions of power yet, unless you consider the power of one person to be power to make a difference. And frankly, I do. And as I get ready to wrap up the slides and open up to your questions, I have to tell you, I don't know what possessed you to spend a vital hour of your time to watch this evening to learn a little bit more, but I know why I work to combat climate change and why I want everybody to know as much as they can. And it has to do with these people, particularly these two, because that happens to be our daughter and our son. And I care about not only what they inherit, but what their as yet unborn children inherit and what their children inherit, because they didn't bring this about. But it is simple because we understand the science and we have all the way back to the 1800s. You know it's serious. You see and hear about it every day yourself, and the impacts are only increasing. And we know what we need to do to make changes. We have agents, we have agency, but there is urgency, and we need to be aware of that. Special thanks to Scott Denning at Colorado State University, wonderfully helpful in putting all of this together. Thank you, Scott, great guy. And I'm going to end and keep this up because almost always my first or second question was, what are things that I can do? And of course, as somebody who is even thinking about being an EDF Action member, you're thinking about things you need to do. And I'm going to go over them briefly before I open it up to Q&A. I put at number one, for a very good reason, talk to people about climate change. One of the things you're going to get as a follow-up to this presentation is some tips I have, some on-the-ground useful tips about how to start conversations with people about climate change. I know sometimes they're uncomfortable. I know I've had a lot of them. It doesn't get easy sometimes, but there are some tips that really matter. And the fascinating thing is that about 70% of Americans are either concerned or seriously concerned about climate change. 70%, number keeps going up. But less than a third of us ever talk to anybody about it. Wow, what a disconnect. Now, I can think of a few reasons for that disconnect, but let's not focus on that. Let's change it. Let's change it starting right away. One of the things I say at the bottom of this, you can't see it on this particular slide, is please pick at least 2 of these things and do them in the next week. I'll go over the rest briefly. Plant trees or preserve the ones that are there. I talked about that before. If you can fly less, great. If not, purchase carbon allowances. A marvelous website is carbonlighthouse.org. Eat less meat and dairy. Now, numbers 4, 5, 6, and 8 save you money. So those are things to have an extra bonus. Number 7, if you have the ability to invest, do so responsibly with climate change in mind. Join local groups, put in your own state, groups that tackle climate change. Obviously, EDF is wonderful about that, but there are many other groups that do that as well. And of course, we are in election season. Remember to vote with climate in mind. Take the time to find out how different candidates at different levels feel about climate change and what they think about it. Finally, if you want to learn more about this presentation, weatherchris.com is my very simple little website. There are hundreds of great websites to find out more about climate change. That's just about this presentation and how it might come to an area near you. And absolute, finally, solution videos. If you want to learn about, in short, easy to digest ways, drawdown.org, they do a tremendous job at producing easy to understand videos that are very, very good. And I would recommend you go to a place like that. I have some books if we want to talk about some books that I would recommend as well, but I'm going to jump over and try and look at some of the questions and turn it over to our moderators while I read some of these questions and take a sip of water.
All right. Thank you, Chris. We can post one of the questions that we have in the chat in just one moment here.
Let's see.
Is it up? There it is. Okay. From
Okay.
Barnett.
Why isn't more education? Thank you for a great question. Why isn't more education on this subject given in daily local weather reports? Well, we're trying. It's a tough one. And I did that for many years myself. I did it. I presented it. I should have presented it more. I retired from full-time television in 2018 and have been very, very busy since then. But more and more local meteorologists are talking about it. In some cases, they get some heat from their management, being totally honest with you. In some cases, they do. In many cases, they don't. But the organization I mentioned at the beginning, Climate Central, is hugely important in helping to educate broadcast meteorologists so that they talk about this more. And in your particular city, they may not do it much, or maybe not the station that you're watching, but some of them do. And just like you might want to tweak who you vote for based on climate action or lack thereof, you might want to change the station you watch based on whether or not and how often they talk about climate change and how it interacts with the daily weather, because those local meteorologists are the very best people to educate people in their local area about what's happening. They literally deal with it every day.
Yeah.
Next question.
And I will say this is that Al Roker, who is on NBC's Today Show, does talk a lot about climate change, and he's done a lot of work in uplifting the issues that we're seeing with the weather and things like that. So I will say that NBC is pretty good with that.
And Ginger Z on Good Morning America does a tremendous amount of education for the ABC. She's the chief meteorologist for ABC. I know that Ginger is doing a lot of great work on it as well.
Absolutely. Great. So one of the questions that I had come through on my phone for you.
Okay, I'll take it.
Yeah, hang on. Let me get back to my notes here. It says, so this has been a milder summer in comparison with the last several years, but yet we've had more rain. Is this still part of climate change?
Well, the vagaries of one year to the next, while they're impacted by a changing climate, there is variability, and we need to be really clear on the difference between weather and climate. The weather, even over a 3-month period of time that we call summer, is still weather. Climate is the weather over a very long period of time. So that's my way of saying that you can have a hotter, drier summer. You can have a cooler summer, although we have fewer of those than we used to, cooler than normal seasons, but you still can, as I mentioned before. So the fact that wherever this person is, that their summer has not been as hot, but it's been rainier than before, we're going to have these fluctuations in many areas as we continue to move through a climate change world. The difference is that it's going to be more likely that we have higher heat. It's going to be more likely that we have more intense storms. It's going to be more likely that we have periods of drought. So when we talk about climate change's impact on the weather, it's probably best to frame it by saying climate change made this particular weather somewhat more likely. It made it twice as likely, perhaps. We try to assign attribution values like that where we can, but the difference between climate and weather is important. And even in a changing climate, we are going to have some weather conditions and weather periods that are very similar to the way they used to be before. They just don't happen quite as often or last quite as long.
Okay. All right. And we just had Catherine also put in the chat, which I happen to know that Catherine is in Rochester Hills, where I will say she and I were just chatting over text, 20 power lines down in Rochester just from the storm that just blew through. So there's an impact right there. But Catherine says, in regards to tree planting, I want to ask your opinion about the chance of success to try and keep pace with the destruction from stronger wildfires.
I wish I could tell you, because on a global scale, that's very, very difficult to know. But here's what I do know is that some trees are going to burn. They always have. More trees are going to burn than what used to happen. So the more that we can plant and the more that we can preserve, the better. And when I talk about preservation, I'm not just talking about in someone's subdivision, although that matters. I'm talking about stretches of boreal forest in other parts of the world. I'm talking about sections of the Amazon. We're talking about preservation in other parts of the world that's every bit as important as what we do, but more difficult for us to impact. So there again, we kind of go back to that old saying, what is something that I can do? I may not be able to prevent some trees from burning in a wildfire, but I can plant some trees. I can preserve some trees. And whether or not it will end up being zero sum, that we'll plant as many as burn, can't tell you that. It's way too hard to compute. But I can tell you that every one we plant is one more than was there. Every one that we preserve is one more that we have to continue to do the good work that trees do.
Yep. All right. And I think we have one last question here from Rose Garber. Rose is a longtime volunteer with EDF Action. Thank you, Rose, for joining us today. And this is a great question. Rose asks, I can't get some past the idea that climate change, yes, there is climate change, but it has always been, and it is cyclical. Short of pulling out charts, what are your suggestions, Chris?
Rose, it's a great question. And I will tell you that you're going to get some guidance on this from some of the attachments that are going to be on the email that come after this. But I love the question because I've gotten it many times myself. Probably the best way to attack that is to just say, yes, the climate has always changed, but it has changed over millions of years, very slowly, and we have not had billions of people on the planet trying to adapt to the changes. I could really get into this, but part of where this question is coming from is that people just want something easy so they can put this aside and not worry about it. They can just say, climate has always changed. We don't need to worry about it. It'll be fine. What we need to help them understand is that we are changing it much, much more than it has changed naturally in the past over a much shorter scale of time. And when the climate changed millions of years ago, we weren't around. It didn't matter nearly as much as it does now. So if you want to try to boil it down to 3 simple things, you have to dislodge people from their little comfort area that they want to excuse this so that they can move on with their regular lives. We have to, as gently as possible, help them see the difference. And the difference is we're doing it. It's much more than ever before, and it impacts in ways that we have never had before. Let me be really blunt. Sometimes I hear people say, we want to save the planet. You know what? I'm going to be really blunt and tell you, the planet's going to be fine. It's been around for 4.5 billion years. And even the things that we might do to it, the planet's going to be fine. But there are 8 billion human beings on it. And if we continue doing what we're doing, billions of them are not going to be fine. And that's the truth. That's what we need to try to get through. And it's blunt. I hope that
Agreed.
helped.
Well said, Chris. And that is just a great way to say we all need to be good stewards of our planet. And talking about climate change, I think, is a wonderful first step in that direction. And Chris, I think you provided so many really great recommendations. I will let everybody know that if you signed up through our Mobilize link to attend this event tonight, I will be sending out an email, and I will follow up with some links to some of the things that Chris referenced today. I'll be sending out a link to this live recording. So that way you can watch it again, or you can share it out with friends and family. But yeah, and also in the chat, EDF Action, we do have exciting events coming up. One of the ways that I would recommend that you can get involved is to get involved with EDF Action. We are, like we said, we are nationwide. I'm the Michigan organizer. So if you're in Michigan or even in the Great Lakes region, I look forward to connecting with as many of you as possible, because we are building support around good climate legislation and policy. And we hope that you can help us in that fight. And in the chat, on Saturday, September 7th, which is the weekend after Labor Day, we'll be virtual again at 12 noon Eastern time. And we will be kicking off our work into campaign season. We work to elect climate champions across the United States, and including Michigan. We're in a swing state. We support anybody who's running who has deep ties in climate work and can help us move those policies forward. So I hope to see lots of you on September 7th as well. Also in the chat is a petition link. If you'd like to get connected to EDF Action, that's also a great way to do that. And yeah, let's chat. I think that we have lots of ways for you to get involved. And if you can't do something directly with us, we have lots of resources to get you to where you want to be. Because we work with coalition partners all across Michigan and across the United States as well. So I encourage you to reach out. And I hope to hear from lots of you in the coming weeks and months. And let's finish off 2024 in a very strong way, and let's really make things happen in 2025.
Thanks, Tina.
I just want
to add real briefly, if anybody has any particular questions for me that you didn't have a chance to ask, please reach out to me. I will respond to all questions. Tina probably has a way to get in touch with me, and I won't mess with those logistics, but you can also reach me through my website, weatherchris.com. So thank you for attending. Thank you for your attention. And by all means, reach out to me if you have any questions. I know there was a lot to get in a short period of time. Thanks again.
Thank you, everybody.